Welcome to online video training for CTI's Janus Workbench software. This is Course 1, Part 3. Getting started programming. Running time, 15 minutes. Let's get started. Workbench requires a PC running Windows 7 or greater, with at least 4 GB memory. Download and install the software from the CTI website at www.controltechnology.com. Workbench is dongle licensed. If you don't have a dongle, it will run in demo mode for 14 starts. If you would like to see how to install Workbench, click the banner above. Otherwise, we'll get started programming. Once Workbench is installed, start the application. This is how the Workbench screen appears when no application is loaded. Create a new workspace or project list by selecting Files, New Project List. Enter the desired name for the workspace. Here, we'll call it Workbench Training Course 1. The workspace is created with a blank folder, ready to add projects. We'll create a new project by selecting File, Add New Project. The project wizard comes up. Make sure you highlight the choice, Project, at the top. Enter the destination folder where you want the project stored. Then enter the project name and a description. Project names are limited to 15 characters. Click Next to go to the next step in the wizard. Select the default programming language to be used. We'll use ladder diagram. This choice isn't critical, because each time you add a program to the project, you'll be able to select the language for that program. For compiling options, you would usually select Debug at this point. Now enter the IP address of the target device, if you know it. This can also be added later in the project settings dialog. Keep the 1100 after the IP address, as this is the standard port number used by Workbench to connect to the target. Leave the remaining settings at their defaults, then click Next. On the I/O and networking dialog, add the communications channels you plan to use, including local, remote, and Profibus I/O, if this project is for a CPU. You can also add these later, so the choice is not critical at this point. Leave the remaining items at their default settings, and click Finish. This will bring up the product selection dialog. In this dialog, you'll enter the product type and firmware revision of your target device. Workbench uses this information to ensure that your application only uses features which are supported on your target device. To avoid problems later, it's important that this information is accurate and entered correctly. You can either enter the information directly into the fields, or, if your target device is currently available on the network, you can use the Auto Detect feature to query the device and automatically enter the correct information. Click OK when complete, and Workbench will create your project. The project is created according to a standard template. Let's have a look at what's there. The folder, Exception Programs, contains the default programs for handling errors. The folder, Programs, contains the individual programs that are developed for this project. A default program has been created, called Main. The Watch folder gives you a place to store monitoring and troubleshooting items, like spy lists, recipes, graphics, soft scopes, and test sequences. A spy list is a list of variables whose value is updated during runtime execution. A recipe is a set of variables that have predefined values, which can be transferred to the runtime, as a group. Graphic screens allow you to create graphic displays, which can be animated while running in the simulator, or on a remote target, using real-time values of the project variables. A soft scope enables monitoring of designated Boolean or numerical variables, and displays the values in a trend chart. We'll learn to use these debugging aids in Part 8 of this training course. Initial Values opens a window which allows you to edit the values variables will be assigned at a system cold start. Binding Configuration is a shortcut to the variable binding editor, which allows you to define how variables are shared between projects. Global Defines takes you to the Global Defines dialog, where you can define what programs are run on system exceptions, as well as create other system definitions. Variables opens a window for creating and editing variables. Types allows you to create new data types and structures. The project organization created here is a guide only. You are free to create whatever kind of hierarchical folder organization you prefer for storing the elements of your project. Let's look at the Project Settings dialog. To get there, click the project name to highlight it, then select Project Settings from the menu bar, or right-click on the project name and select Project Settings. The dialog for Project Settings is organized into 5 categories for quicker access. If you're not sure of the category for a particular setting, you can select the All category to see all the settings. Let's look at some of the most commonly used settings. In the General category, the Communication Parameters setting allows you to set or edit the IP address of the target system. The Cycle Time setting allows you to set the system to run as fast as possible, or on a fixed scan time of your choice. The Code Generation setting allows you to select between debug and release mode operation. Typically, debug mode is used until the application is ready for production. Debug mode must be selected in order to use breakpoints, trace points, and step-by-step debugging. Release mode improves performance by 10 to 20% when debugging is not required. The Online Change setting allows you to specify whether the project will allow the program to be modified and replaced while the target application is running, subject to certain restrictions. When Online Change is enabled, this dialog allows you to set values of reserved memory to hold the changes. The project version number is incremented by 1 each time the project is compiled. The compile date and the compiler revision level are appended to the end. Double-click on the value to reset the version number to 0. In the Runtime category, the Runtime System setting allows you to specify the byte ordering of the processor. For 2500p-ACP1, select Big Endian byte ordering. For 2500p-C2XXX processors, select Little Endian byte ordering. In the compiler category, the Runtime Password setting allows you to specify a password for the target application. A blank indicates that no password is defined. If a password is specified, the user will be required to enter it each time a remote connection is established with a target. In the debugging category, the Download Procedure setting allows you to specify the items that will be downloaded to the target, along with the compiled application. By editing this setting, you can force the download of source files to the target each time the compiled program is downloaded. Here, we've covered the key project settings, but there are many additional items which give you control over how your project is compiled and executed. Consult the Workbench help file, or Course 1 training manual for more details. Next, we'll create a new program. Highlight the Programs folder, and right-click, then select Insert New Program. Enter the program name and description. Select the language that will be used for this program. We'll use ladder diagram. Then select whether this will be a main program, subprogram, or UDFB. We'll use main program. Click OK, and your new program will be created and displayed in the Programs folder. Before we start programming, let's edit the project cycle, which controls how often our program runs. Highlight the project name and right-click, then select Cycle. The execution order of programs can be adjusted by highlighting the name, then clicking the Move Up or Move Down buttons on the toolbar. Execution of individual programs can be enabled or disabled by clicking the checkbox in the Enable column. The period parameter sets how frequently the program executes. For example, if the period is set to 3, the program executes on every third scan. The phase parameter offsets the start of execution. For example, a program with period 3 in phase 1 will execute on the 2nd, 5th, and 8th cycles, and so on. The graphic at the right of each program shows the execution pattern. Click the X to exit the cycle dialog. Now, we'll double-click the practice program we created, to open it for editing. Let's look quickly at the parts of the Workbench editing screen. This is the main editing pane, where you can open and edit programs, watch lists, variable binding, graphics, etc. This is the Workspace pane, which shows your projects organized into folders. Double-click an item in this list to open for editing. This is the Output pane, which reports messages, and provides diagnostic tools. This is the Variable Editor pane, where you create and edit variables. This is the Object Selection pane, where you can access functions and function blocks, spy lists, and graphics. The status bar shows the status of the connection to the target device. Let's enter our program. Click the Insert New Rung icon in the ladder editing toolbar to create a rung. Double-click on the contact to enter a variable name. Enter motor start. Click OK. The new variable dialog box will come up, because you have entered a variable motor start, which has not been defined yet. Select bool, and enter the description. Click Yes. Look in the variable editing window. Expand the practice program, and you can see the variable that was created. Motor start is presently a local variable. Let's make it global. Highlight the motor start variable, and drag it down to the global variables section. Let's set an initial value of true, for the motor start variable. Double-click in the init value column, and type true in the box that comes up. Here enter, and now the initial value is assigned. We'll repeat this process to assign a variable motor run, to the output contact. We'll make it global. And since this is an output, we won't assign an initial value. Now, we're ready to compile and run our program. Click the Build Startup Project icon. The project will compile, and the results are shown in the Output pane. Inspect the Output pane, to ensure there were no errors in the compile. To run the program in the simulator, we'll click the simulation icon. The Start Mode dialog box will come up. In a cold start, all variables are set to their initial values, as set in the program. A warm start sets, retain, variables to their last value. A hot restart sets, all, variables to their last value. Since we haven't run this program yet, cold start is the only option available. Click Start, to run the program. Notice that while running, we can view the value of motor start and motor run, in the program editing pane, and the variable editing pane. To change the motor start variable while running, simply double-click on the contact in the program editing window, or on the variable name in the variable editing pane. A dialog will come up, allowing you to change the variable. Click True or False to change the value. In this program, the motor run output should follow the value of the motor start input. Clicking the Lock box will lock that variable and not allow it to be changed, regardless of whether the input changes. This is equivalent to forcing, in Workshop. When changing the value of a numeric variable like an integer, the editing box looks a little different than for a Boolean. To change the value, enter it in the space provided, and then click Force. This will reset the value of the variable. Note that forcing works differently in Workbench than in Tysoft and Workshop. Forcing in Workbench resets the value of the variable, but the program is free to continue changing the value. Use the Lock, Unlock, and Lock plus Force, activated by clicking the box next to Lock, to freeze or unfreeze the value of the variable and prevent the program from changing it. Note you can also use the checkboxes at the bottom to set or clear individual bits. You can pause and resume simulation, using the control button at the top. The status display shows the run or stop state. To exit simulation, click the simulation icon again. This completes Course 1, Part 3. Here's a summary of what we've covered so far. Introduction to Workbench in IEC 61131. Basic concepts of Workbench. Getting started programming in Workbench. Create a project list. Create a project. Edit project settings. Create a program. Edit the project cycle. Know the main components of the Workbench screen. Make a simple program and run it in the simulator. Change the values of variables during simulation.